Hello and welcome, everybody. Happy Friday to you all, and welcome to math class. Grab a seat. Make sure you have all of the supplies needed over there. Something to write on, something to write with. Here's our topic for today. Here's the I cans, and let's get into it. We're going to be adding some fractions today. Yesterday we talked about fractions as a concept and what it really means to be a fraction, thinking about it as part of a whole number or a portion of a quantity that's divided into equal groups. Okay, I've got let me lower this slightly. There we go. Here is our definition from yesterday of the two key terms that we're going to need for really talking about fractions in a mathematically accurate way. So on the top, we have our numerator. That's the number of pieces we're talking about, or the number of parts that we're talking about in relation to our whole number, okay, or our whole quantity. And then on the bottom, we have our denominator. That's the size of the piece. That's letting us know, okay, we have our whole amount, our whole quantity. How many equal pieces is that quantity divided into? And then the numerator lets us know how many of those pieces do we have. When we are adding fractions, okay, a great thing that emerging mathematicians do is they just use their intuition when they're adding fractions, and they go, okay, well, stands to reason if I'm adding a whole number, like I'm adding 5 plus 5, right? 5, and then 5 more, right? So if I'm adding a fraction, it stands to reason I should just like add the top and add the bottom. Makes sense, right? When we draw it out visually, we start to see why it doesn't actually work to add fractions just straight across. Add your numerators, add your denominators. Let's take a look at that. So, let me move that all the way over. There we go. So, to start us, we've got something I see a lot. This is this idea of when we add fractions, we're going to add the numerators, we're going to add the denominators, and there's our answer. But when we draw it out in sort of this visual form, we start to see that that strategy doesn't quite work. That formula doesn't quite work. So let's take our problem that's up at the top. We have 1/4 plus 2/4. And I went ahead and I wrote out our addition equation kind of as fraction bars. And remember, when we're talking about using these fraction bars, and when we're talking about fractions in this case, each fraction bar equals 1. They have the same value, okay? Each fraction bar equals 1. Can you take a fraction of any number? Certainly, okay? But for intents and purposes, for this lesson to get us started, each fraction bar is going to equal 1, okay? So let's set up our problem to start. 1/4 plus 2/4. Okay, so I've shaded in 1/4 of the top fraction bar, 1/4 of 1, and I've shaded in 2/4 of 1 on the bottom fraction bar. When we're adding these together, we should come up with an equal value, or because our fraction bars all have the value of 1, an equal size on the bottom. But if we do our adding of the numerators and our adding of the denominators, it ends up looking like this with 3/8 on the bottom. You see, I've taken our fraction bar, divided it into eighths, and now let's color in 3 of them. Now, I can already tell that this equation might have an error here. And the way I can tell is by looking at our 2/4 and then looking at our 3/8. Which one's larger? Our 2/4 is actually larger. And when we're adding two positive quantities together, two quantities bigger than 0, we can't go backwards. We can't end up somehow with less value, okay? Because what happens when we add up the denominators is we're making the size of our piece smaller. When we add our denominators together, what we're doing is we're changing the size of our piece. Okay? This is like if you had one large pizza plus 2 large pizzas and you ended up with 3 small pizzas. Doesn't quite work and doesn't give us an accurate answer for what these 2 quantities added together actually would be. Okay? Let's take a look at instead, well, first let's think about, and let's think logically here. If we have one of these pieces and we add 2 more of these pieces, logically we should have 3 of those pieces, right? So what we do in that case is the size of our piece doesn't change. When we're adding or subtracting, the size of our piece or our denominator doesn't change. And our denominator needs to be the same size in order to add it up in really an accurate way. Okay? Next week, we're going to get to what do we do when our denominators aren't the same and we have to make our pieces the same size. But for today, we're just going to be dealing with fractions with like denominators, fractions where the pieces are the same size. So let's take a look at this problem, but in a way where we aren't changing the size of our piece. It looks like this. Okay, what we have here is 1/4 plus 2/4 equals 3/4. And we can really see clearly in our visual that, yeah, that makes sense. That one piece really can just move to this open spot, right? And we end up with 3 pieces total, or 3/4. Okay, so when adding fractions with like denominators, and also with subtracting fractions with the like denominators, the numerator, so the number on top, will change and the denominator stays the same. That is our golden rule for adding and subtracting fractions, is the numerator changes, the denominator stays the same. Let's move to our digital whiteboard and we're going to practice a few. So here's our first one. 2/8 plus 3/8 equals what? And I went ahead and included a fraction bar below that's cut into eighths. I would recommend doing that as well on your paper, is drawing it out. I think that really does help visualize and see what we're dealing with here. Okay, so if I shade in 2/8, I'll use the rainbow pen for this. There's no harm in that. I'm going to shade in 2/8. And then I'm going to add my 3/8 to it. Remember, because our pieces are the same size, we can add them together. Okay, so here's our 2/8. And now I'm going to add our 3/8. Use the other rainbow pen so we can see the difference. Okay, same size, but I'm just differentiating which add end we're moving in here. Okay, so now let's think back to yesterday's lesson. What's the size of the piece? The size of the piece hasn't changed. It's still eighths. Okay, but then how many pieces do we have total? 2 plus 3 is 5. Okay? If we had added our eighths together, we would end up cutting each one of these eighths in half to make 16ths, and we'd end up with an inaccurate answer. Okay, so 2/8 plus 3/8 equals 5/8. Let's try another one, and this one's got a little bit of a trick to it. 3/5 plus 4/5. Okay, I've started us with a fraction bar in fifths. But I want us to notice something. 3/5, let's shade that in. Here's 1/5. Here's 2/5. And here's 3/5. Now we're going to add 4 more fifths to this equation. Do we have space for that in this fraction bar? If we don't, here's what we do. We're going to make another fraction bar. And again, remember, our fraction bars in this case are always going to equal 1. And because the size of our piece hasn't changed, we're going to divide this fraction bar also into fifths. Okay, so we're still working in fifths. There might be 10 pieces here, but we're still working in fifths because each whole number, each 1, is divided into 5 equal pieces. Okay, then we're going to add, now we have room to add 4 more fifths. 1, 2, 3, and 4. Okay, so for our answer, remember, the size of our piece has not changed. It's still in fifths. Okay. Total, actually, right now, our 2 fractions bars make what? 5 plus 5. There's 10 pieces total, but since the size hasn't changed, we're actually seeing a total of 10 fifths down here. And then how many are shaded in? 1, 2, 3, 4, 5, 6, 7. Okay. Alternately, you can write this as a mixed number if you choose, because we can look at how many whole numbers do we have? How many full ones do we have here? We have 1 full 1. So I'm going to put an or. And then I'm going to put 1, because this is our whole number. And then how many fifths are left over? 2 fifths. Okay? So both answers, 7 fifths or 1 and 2 fifths, both answers are acceptable. All right. I'm going to give you a couple more to try on your own before we get to the exit ticket. Okay, so there's our 2 practice problems there. So think about for these 2, what do I need to divide my fraction bar into? How many equal pieces? And then we'll add our numerators together. Go ahead and I'll give you a little bit of time to copy these 2 down in your math notebook. I'm not going to give you the answers for these just yet. Go ahead and copy them down and give them a try on your own. Reminder, our class Zoom room will be open after this lesson is done. If you are wanting some feedback or wanting to ask more questions about adding fractions, feel free to drop in. I will be there and I will be ready with my whiteboard ready to help. Okay, let's take a look at this first one here. 1/6 plus 4/6. So we're going to divide this into 6 equal pieces. Whoops. 1, 2, 3, 4, 5, 6. And then we've got 1/6 plus 1, 2, 3, 4/6. All right, for a total of 5/6. Remember, the size of our piece hasn't changed. The size of our piece stays the same, and that's our denominator. Okay. Similarly with this one, 5/9 plus 8/9, we can go ahead and keep our denominator the same. And often, that's a good reminder for us. Just write in that denominator right away. Then all you have to worry about is how many pieces, right? So let's divide this fraction bar into 9ths. Remember, when I'm freehanding these, it's not exactly 9 equal pieces. It's 9 equal pieces-ish. I don't want to get the ruler out. And then let's shade them in. So we've got 1, 2, 3, 4, 5 plus, so we're going to go greater than 1 because we don't have 8 more 9ths left. So we're going to draw our second fraction bar. Now we're dealing with 2 rather than 1. And then we can go 1, 2, 3, 4, 5, 6, 7, 8. All right, and remember, our denominator stays the same. We're not changing the size of our piece. Okay, 5 plus 8 is 13. Or we have one whole number, and then how many extra ninths? 1 and 4 ninths. Okay, you can either write it as an improper fraction that's greater than 1, or you can write it as a mixed number. Either one is an acceptable answer because they both have the same value. Thank you so much for tuning in today. I really do appreciate it. I'm really, really proud of all your hard work this week. I think it's been a fabulous first week of live lessons. I can't wait for next Tuesday when we will be here not only at 10:30 for math, but we will also be here in the afternoon to talk about some writing. I completely lost my sentence, so I'm just going to scrap it and move on. Thank you for being here. Remember, fill out that exit ticket by noon. Come see me in the Zoom room if you have questions or want feedback on your work. And have a wonderful rest of the day. We'll see you in the afternoon for our closing meeting. Sayonara.